Hello friends, this is Mr. Vipul Sansari. Once again welcome you in our new video lecture. So today we are going to see some important topic related to physical pharmaceutics, that is hydrophilic lipophilic balance. So we will see what is meant by hydrophilic lipophilic balance and what is the importance of this HLB scale and how to calculate the HLB value of particular surfactant. So first of all, we will see some important points related to the surfactant. So these surfactants are extraordinary class of compounds and these are amphiphilic in nature. The amphiphilic nature indicates the affinity of a compound to both polar as well as non-polar type of solvents. So why these surfactants are amphiphilic in nature? Because these contains the two different types of functional groups in their structure, that is polar as well as non-polar type of functional groups in a surfactant structure. So where these polar and non-polar type of functional groups are exist in the surfactant structure, that also we will see with the help of diagram. So here you can see the surfactant contains two distinct parts, that is two different parts. So first is polar head, the polar head group, which is responsible for hydrophilicity or affinity of a surfactant to the aqueous or hydrophilic medium. The second group is non-polar tail. So this is tail-like long chain portion of surfactant which is responsible for the non-polar or hydrophobic characteristics to the surfactant. Now most important property of the surfactant, these are also known as surface active agents. So these agents are very much active on the surface as well as interface, and they have ability to reduce the surface as well as interfacial tension. This property of a surfactant is basically utilized for in the various formulations as a stabilizer. So surfactants are used as a stabilizers in a disperse system like a suspension and emulsion. So while selection of proper surfactant for the particular type of disperse system, the hydrophilic lipophilic balance of the surfactant plays a key role. So what is this hydrophilic lipophilic balance? So this HLB is basically a scale that indicates the extent of polar and non-polar nature or a character of a surfactant. So how much the surfactant is hydrophilic and how much it is lipophilic. That is balance between the hydrophilic and lipophilic portions in the surfactant molecule is basically assess or basically understand based on the HLB system. So as I told earlier, this is a basically arbitrary scale. So this scale is derived by scientist Griffin in 1949, and later some development in 1954 introduced a scale that is HLB scale, and it is a semi-empirical method. So according to HLB scale, the surfactant can be categorized with HLB value between 1 to 20. So those surfactants which have HLB value 1 to 10, 1 to 10 are preferentially lipophilic in nature, and those surfactants have HLB value 10 to 20 are preferentially hydrophilic in nature. So based on the HLB value, the use of surfactant is also different. So HLB value 1 to 3, those surfactants have HLB value 1 to 3 are used as anti-foaming agents. Those surfactants having HLB value 3 to 8 are used as a stabilizer or emulsifying agents for the formation of water in oil type of emulsion. Those surfactants having HLB value 7 to 9 are used as a weighting as well as spreading agent in pharmaceutical formulations like a suspension. Those surfactants having HLB value 8 to 16 are used as a emulsifier or stabilizers for formation of oil in water type of emulsion. The surfactant having HLB value 13 to 16 are used as a detergent. Then last, those surfactant having HLB value 16 to 20 are used as a solubilizers for solubilization of poorly water soluble drugs. So these are some important class of surfactant, or sorry, important use of a surfactant according to their HLB values. So we'll see. Now based on this scale, you can easily understand the surfactant which have more HLB value, they are preferentially hydrophilic surfactant, and surfactant which have less HLB value, these are preferentially lipophilic surfactants. So the surfactant with low HLB value indicates that the number of hydrophobic groups or lipophilic groups indicates in a, present in a surfactant are more. So low HL value indicate the hydrophobic or lipophilic groups in the surfactant structures are more, and the hydrophilic groups in the surfactant structures are less. So less hydrophilic groups indicates the preferential lipophilicity or hydrophobicity of the surfactant. Right? So the surfactants are lipophilic characteristics. In opposite, the surfactant with high HLB value, this surfactant contains more number of hydrophilic functional groups in their structure. So these are hydrophilic in nature. So these are some important surfactants along with their uses just for your understanding based on their HLB value. Now you can see here the surfactant with HLB value 7 to 9 are used as a emulsifying agent to form water in oil type of emulsion. So example is SPAN, that is sorbitan ester, sorbitan monolaurate. It is ester of sorbitan and lauric acid, right? Sorbitol and lauric acid ester, that is SPAN 20. So here the HLB value of this SPAN 20 is 8. Whereas you can see here HLB value of twin 80, HLB value of twin 80 is 15 to 16. So the HLB value of twin 80 is more than that of SPAN 20. So twin 80 is more hydrophilic than SPAN 20. So you can compare the surfactants based on their HLB value, right? Which surfactant is more hydrophilic and which surfactant is more lipophilic. So as I told earlier, the SPAN have low HLB value. So these are lipophilic surfactants. So they exhibit the solubility in oil. Thus, the SPAN can be used for the formulation of water in oil type of emulsion, because oil is your dispersion medium and surfactant should be solubilized in dispersion medium. Right? So SPAN can be used as a stabilizer for water in oil type of emulsion. The higher HLB value indicates the more hydrophilicity of a surfactant. So example is twin. Have high HLB value 15 to 16. Right? So these are water soluble surfactant. And this surfactant can be utilized for the formulation of oil in water type of emulsion. Right? Because these are water soluble emulsifier, that is twins. Now how you will estimate the HLB value of surfactant or surfactant mixture, right? So basically three different methods are used. So first method is put forwarded by Davis and Ryder, and according to this method the HLB value can be calculated based on the functional groups present in the surfactant structure and their contribution, whether it is positive or negative contribution to the hydrophilicity of a surfactant. So surfactant structure contains functional groups, and based on the contribution of this functional group to the hydrophilicity of a surfactant. Some surfactant contributes to the hydrophilicity of a surfactant, right? And some functional groups contributes to the lipophilicity of a surfactant. Right? Now those functional groups which contributes to the hydrophilicity of a surfactant can call as a positive contribution towards the hydrophilicity. Those functional groups which contributes to the lipophilicity of surfactant can call as a negative contribution towards the hydrophilicity, right? So HLB can be calculated using simple formula, that is summation of hydrophilic group minus summation of lipophilic group number plus 7. So this Rydell and Davis basically give the number to the each group, that is group number, and summation of the hydrophilic groups and summation of the lipophilic group. Based on these two the group numbers, you can calculate the HLB value. For example, we will see. So these are some group numbers of various groups. Now lipophilic groups. Here methyl group is there. Then CH2. Basically these are the hydrocarbon groups, because the lipophilic tail portion of a surfactant, the lipophilic tail portion of a surfactant contains the hydrocarbon chain. So hydrocarbon groups are there for the lipophilic groups, and this group have specific number. For example, methyl group have number 0.475. Then hydrophilic groups, these hydrophilic groups form the polar head of a surfactant, and which consist of some heteroatoms and ester group in their structure, right? So these are some hydrophilic groups and their respective group number. So based on this group number, you can calculate the HLB value of a surfactant, right? So here is the problem. Calculate the HLB value of sodium lauryl sulfate. The structure of sodium lauryl sulfate is given. Now, in this structure, the hydrocarbon chain, right, that is 12 carbon containing hydrocarbon chain, right, is basically contribute to the lipophilicity of a surfactant, right, and group number of this hydrocarbon is 0.475. So this contributes to the lipophilicity, right, whereas group number of sulfur sodium ions is 38.7, right. So this 38.7 group number of these ions contributes to the hydrophilicity of a surfactant. So just put the values in this equation. So only one sulfur sodium ions. So just 38.7 minus summation of group number of lipophilic groups. So here total 12 different groups are there which contributes to the lipophilicity. So 12 into group number of that respective groups, that's 12 into 0.475 plus 7 according to formula. So once you solve this, you will get the value, that is 40. So sodium lauryl sulfate, the calculated hydrophilic lipophilic balance value is 40 according to method 1. Second method is based on the percentage by weight of ethylene oxide chains and polyhydric alcohol groups in the surfactant structure. So according to this method, the HLB value can be calculated using simple formula, that is E plus P divided by 5. So E indicate the percentage by weight of ethylene oxide chains and P indicate the percentage by weight of polyhydro alcohol groups like sorbitol, glycerol, right? So ethylene oxide chain we have discussed already, these are present in twin surfactant structure. So how much is the percent by weight of this ethylene oxide chain and how much is the percentage by weight of polyhydric alcohol groups which contributes to the hydrophilicity of a surfactant. So based on these two different weights, you can calculate the HLB value of a given surfactant. Then next method is based on saponification number and acid number of surfactants. So surfactant HLB value can be calculated using formula, that is 20 into 1 minus S divided by A, whereas S indicates the saponification number of ester group in the surfactant and A indicates the acid number of fatty acid. So this is simple equation. So if you know the saponification number and acid number, you can calculate the HLB value of surfactant. See the example. Calculate the HLB value of twin 80. If saponification value is 47.5 and acid value is 190, that is 190. Now in the equation they are given the both values. So just put the values in the formula, that is 20 into 1 minus S divided by A. So saponification number value is given, that is 47.5. Acid number value is given 190. So to solve this equation you will get the value 15. So that is HLB value of twin 80. Next other formula, just see they calculate HLB value of twin 20 if the saponification and acid value are 45.5 and 276 respectively. So again the saponification value and acid value both are given. So just put the values in equation and solve the equation. You will get the value, that is 16.7. That is HLB value of twin 20. So you can see here the twin 20 HLB value 16.7 and twin 80 HLB value 15. So if you compare the hydrophilicity of these two surfactants, the twin 20 is more hydrophilic than twin 80. Next, HLB value of surfactant mixture. So if you mix the two different surfactants in fixed proportion, how much is the HLB value of that mixture? You can calculate using the different techniques. Suppose I have one problem, that is calculate the HLB value of mixture of 40% of span 60 and 60% of twin 60. And these two different surfactants I have used, that is span 60 and twin 60. HLB value of these two surfactants are basically known. So HLB value of span 60 is 4.7 and HLB value of twin 60 is 14.9. Now 40% of span 60 I have used. So just calculate the HLB value of 40% of span 60. That is 40% of span 60 is equal to HLB value of span 60, that is 4.7 into 40 divided by 100, because 40% of span 60 I have used. So if you solve this you will get the value 1.9. Then 60% of twin 60 I have used. So 60%, that is 60 divided by 100 into HLB value of twin 60, that is 14.9. So once I solve this I will get the 8.9 as well. Now these two different surfactants I have mixed. So HLB value of mixture you can calculate using summation of this calculated HLB value of fractions. That is 1.9 plus 8.9. So total 10.8 is the HLB value of mixture. Next, second type of problem can be asked in your exam, that is calculation of proportions of a surfactant required for the preparation of surfactant with known HLB value. So just see the problem, in what proportion should the twin 80 and span 80 should be mixed to produce the surfactant mixture with HLB value 12. So here we have to calculate the proportion or amount or fraction of twin 80 and span 80, right, to produce the mixture of HL value 12. So you can calculate using the alligation method, right. Now HLB value of twin 80 and span 80 are known. So HLB value of twin 80 is 15 and HLB value of span 80 is 4.3. So just put the values here. The HLB value of twin 80 15 and HLB value of span 80 4.3, and at the center put the HLB value of mixture, that is desired HLB value of mixture, which is given, that is 12. Now subtract the smaller quantity from larger quantity. So 15 minus 12 you will get a 3. So just put in front of this parity, and 12 minus 4.3 you will get a 7.7, right. So now just see the serially 7.7 parts of twin 80 and 3 parts of span 80. So if you mix the 7.7 parts of twin 80 and 3 parts of span 80, you will get the mixture with HLB value 12. The parts indicate you can use the any 7.7 ml of twin 80 and 3 ml of span. If you mix together, you will get the mixture with HLB value 12.